acting, double acting, and under double acting, you have got single rod being attached to the shaft as a shaft. Double rod in the sense, two shafts are going to be attached to that particular shaft. That is how the things are. So in single acting case, what happens is one side of the shaft, one side of the piston only being put into action. Something like that side only the air fluid is rather the pressurized air is going to be admitted. On the other side, we will not have any what do you call air is not going to be admitted onto the other side of the piston. Maybe you can categorize those sides as left side and right side. Pressurized air is going to be either admitted onto the left side or admitted onto the right side. Such a sort of situation, if it is happening, such a thing is being referred under single acting. Coming to the double acting, pressurized air is going to be admitted either into the left side or into the right side of the fluid. Okay, so in that particular process, okay, for a double acting piston, if you have one rod being attached on one side, means you can imagine one connecting rod that is moving forward and backward, something like this. Say this is the piston, say this is your shaft, and this is the rod according to this. If this particular rod is single, then when the piston moves forward and backward, that means this particular rod will be moving only one side of the piston, only on the right side of the piston. That case is actually coming under C, single rod type double acting cylinder. Then, if you have a piston like this, my hand you assume that as a piston, and you have got shaft attached to this side as well as this side. Now this is rod 1, this is rod 2. When the piston is moving, both the rods are actually moving. That is actually coming under category D, double rod type double acting cylinder. Then based on the cylinder's movement, rotating type air cylinder, non-rotating type air cylinder. Okay, so they are going to introduce vane in that. That vane is going to be introduced into that. So vane, when you have, that can go on rotating within the cylinder, and it is something like rotary vane, wherein when the vane rotates, the air being trapped in between, the space is going to be volume is going to be reduced, and because of volume is getting reduced, its pressure is going to go on rising. That way you can imagine. That is how rotating type and non-rotating types are coming into picture. Telescopic, like camera. What happens when you have a zoom camera? In between one shaft there is going to be another shaft, and in that again there is another shaft. Because of that you can bring it out. And rodless tandem type, you will see such a kind of arrangement in IC engines. In rodless, there will be no rod at all. Piston only will be there. No rod at all. That piston moment will be there because of the support of magnetic that you can see here. Magnetically coupled slide. And of course, cable cylinder. We will not see all these varieties. Maybe few out of them we will see in the next portions of the slides. But what you need to do is, out of your interest, if you want, you can dig out and you can go through them. And if you have got really interesting aspects, you can ask me. I'll give you permission. In this particular slot, you will be permitted to present your what do you call, your collected information for a span of 5 or 10 minutes. That's quite possible. And of course, cylinders with sensors, so many varieties are there. We'll try to see some parameters at least to the extent. Okay. Between light duty, medium duty, heavy duty, the information whatever I could gather, I am trying to present it to you. See, let us see this. Piston rods. EN8 is the type of metal that is going to be used. Or similar steel, ground and polished, or chrome plated. Same is the thing even over here. What has been done? EN8 steel, ground and polished, or chrome plated, ground and polished stainless steel. And ground and polished stainless steel, that is the item, that is the material that has been used for piston rods, for pistons, for light duty aluminum alloy castings, for medium duties aluminum alloy castings, brass, cast iron also can be used. Then coming to this aluminum alloy castings, brass and cast iron. See, I would like to bring to your notice that cast iron pistons are being put in use in Volvo buses, which are known to us, which are traveling at a speed of 120 kilometers per hour. With respect to the speeds, when we try to imagine, those people nowadays they are still using cast iron pistons, looking at the advantages and the pressures withstanding capacities, whatever it has got, that have been taken into account, and that is the reason why they are trying to. So this has given a scope for me to give you a clarity on that. That too, in all these instances, they have quoted aluminum alloy castings. Aluminum alloys, different categories are there. Depending upon the requirement, you can select your appropriate alloy. Okay, so don't be under the impression that for light duty, medium duty, heavy duty, same aluminum alloy casting is going to be used. Different types of alloys are going to be taken into account. With them, different types of maybe aluminum alloy casting is going to be prepared. So what kind of casting has been put in use under these categories, I have not collected and brought forward. You please collect, work on this particular area also. Try to collect those alloys. And end covers, high tensile castings, aluminum, brass, bronze, iron, or steel castings over here, and of course brass and bronze also have been taken into account. So this is how this particular table with respect to the mechanical aspects, and you can also get a feel that robots, when that have been put in use, in particular when it is coming with respect to the hydraulic actuators and pneumatic actuators, our mechanical people role is there much more, that you should feel. Then based on the cylinder action, single acting, you can see here piston and seals. Like in the case of IC engines, you have got oil seal, okay, compression seal, so many seals are there. Likewise, even here, you have got a seal. This side you are trying to admit the pressurized air, whereas this side it is not. Only spring is there. Because of that, since you are trying to use only one side of the piston, that is left side of the piston, okay, that is going to be referred as single acting. Other side it is not. If you want me to use the same sketch for the explanation of double acting, alternately pressurized air, in one instance it is going to be admitted on the left side of the piston. In the second instance, the pressurized air is going to be admitted onto the left side of the right side of the piston. Okay, so anyway, this is not the case of that. This is actually single acting only. Then if you come to this, you have got a diaphragm, no piston. So pressurized air when you admit through this, pressurized air when you admit through this is the diaphragm that is not going to displace, but it is going to expand. Its shape is going to be expanded. If you imagine that as a cylinder in shape, a spherical shape of expansion is going to be, you can imagine on those grounds. Okay, that way you can imagine over here. Okay, so soon after that particular pressure has been used and it will be no more, then this particular spring pressure is going to be more, that will be pushing out the compressed air. Okay, so that is how the things are over here. Okay, so let me stop my presentation at this particular instance, because I would like to continue my session with